Precalc chapter outline 1.3, algebraic expressions. Expression is a combination of variables and numbers. What's a variable? Again, I'm not going to write these down. You guys can write them as I speak. What's a variable? Expression is made up of variables, numbers. What's a variable then? Something, yeah, Claire? Letter that represents a number or something, right? It's an unknown, something that has to stand for something else. A constant is a fixed what? It's a fixed number. Constants never change. That's why it's called constant. Domain. If I'm talking about a domain of an equation, actually, the domain, usually in our math, we use what letter? X, okay? So we'll usually use X. The range we'll use Y. Does it always have to be? No. So domain is X, range is Y, but what is domain? How is it used? What do we do with it? Sometimes I like to think of it as your room in your house. You are the ruler of your domain, right? It's because you control it, we'll say. So you control your domain. So you have control. You choose what can go into your domain, or the domain has restrictions that you put in things. The range is what comes out, right? So maybe on control, we'll put input for that domain. This is your output. So you have your output, input, outputs, what you control. You don't control your range directly. It's kind of a function of what the equation is, or the function, or the rule, sorry. So the range is kind of what comes out. Polynomial is an expression that contains one or more terms. So what's a term then? Term is about a product of numbers and variables. Product of variables and numbers, aka constants, right? So like 2x squared is a term. We have a couple different types of terms or groups of polynomials, we'll say. A monomial is a, mono means one, so one term. Binomial would mean two terms. Trinomial, three terms. The degree of a polynomial. The degree is the highest power. I think that's important, so I'll write that down. Usually we put things in standard form. I don't have that listed as one of our things. What's standard form mean? I'll put that as an extra term here. What's standard form of a polynomial? It's when a polynomial is listed or put in order from highest to lowest exponent, right? Or highest to lowest powers. Very generically, a sub n x to the n plus a sub n minus 1 x to the n minus 1, where n is their powers, and it goes all the way down to a sub 1 x to the first plus a sub 0, which is your constant. And this could have the 100th power, 99th power, 98, and so forth as your exponents. The a sub n minus 1 are just different coefficients on those powers. So coefficients, remember, are the ones in front. And like terms, obviously, are terms that have what? Like terms are the ones that have the same variable with the same powers, right? So an x and 2x are like terms. You can add those together to get 3x. These are all things we should know. So we're going to combine algebraic expressions. First, we're going to take polynomials and add or subtract them. I think the hardest of these two choices would be the second one, which would be subtraction. So what we're going to do is, I'll show you again, how to add, and then when we go to subtract, we're going to turn it into addition. So the first thing you need to do when working with adding or gathering like terms is to get rid of your parentheses. Do we technically need parentheses around things when we add them? No, because everything is just going to be added, right? So technically, get rid of your parentheses. So just rewrite it. Next thing I'm going to do is I'm going to write it in standard form, highest to lowest powers. So I hunt for the highest power. What's the highest power? It's x cubed. So what I'm going to do is I'm going to go and the first time I'm just going to underline those. And then I just ask myself, an x cubed plus an x cubed is 2x cubed. Then I'm going to go to the next highest power, which is 2, and I'm going to put those together. Now, I highly suggest that you do something different. So I'm going to put a squiggly line underneath these ones to kind of highlight the fact that I'm putting those two together. Because if you make a mistake, you can go back and say, well, I put these two, oh wait, they weren't like terms, I shouldn't have done that. Or, yes, I put the right ones together, I must have done my math wrong. So now you can ask yourself, what is negative 6x squared plus a 5x squared? It's a negative x squared. Then I'm going to x's. Maybe I'll make a elongated smiley face one, I don't know what you want to call that. Curved line. 2x minus 7x is minus 5x. And I'll use a double line for the last constant. Oh, that's the only one. You've now added them together. It's in standard form. We're all happy. Probably no questions on that, right? The next one, though, as you can see, has a subtraction. And if that's the case, you look at the first parentheses. What's out front of it? It's a positive 1 out front of the first one. The second one, it's really a negative 1. So if I multiply something by 1, it doesn't change it. I can get rid of the parentheses in the first group. The second group, I need to take that negative and distribute it in. After you've done that, it becomes an addition problem, gathering like terms. So we probably won't finish the whole problem with us here, but let's just rewrite it. Bless you. And I rewrote the first group, and now I start to distribute. Now, hopefully, I keep this throughout the year, but you will not generally see me write all three of the arcs multiplying the negative in right away. I will do one arc so that I can write minus x cubed, do another arc to say negative 5x squared, and then make my final arc to say positive 7x. The reason I do not all three in the right way is because it's very hard to show my work. Or I mean, say, follow my work. Because yes, to me, that's showing work, saying, hey, this is what I'm doing, but you draw all three of them in there, and all of a sudden you're like, okay, now which one did I just do? It's not so bad when it's just a single term, but what happens when it's a trinomial times a trinomial, which is coming up? If you don't make those, if you make all the connections right away, then it starts getting messy. And then, of course, go through the same steps we did above, gathering like terms. I'll let you guys do that on your own. So, after you've done adding and subtracting, now we have to multiply. Now, I have up there, is this foiling or is it the distributive property? The one thing I guess I don't have on there is a monomial in, but we did that with the negative 1. The first one, we call it foiling. First, outside, inside, last, yes? The second one, or D, is a binomial times a trinomial. Technically, that's not foiling because there's more than just two terms in each. That is using the distributive property, because foiling is distributing as well. And so sometimes I'll even refer to the part D as double distributing. But let's put these together real quick. So 2x times 3x is first, which is 6x squared. 2x times negative 5, negative 10x, plus and minus. Remember, when almost, not say every time, but a lot of the times when you FOIL, you end up with this situation where you have to gather your like terms in the middle. So you get 6x squared minus 7x minus 5. Make sure to put everything into standard form. Number one, it makes it easier to work with or compare with somebody else. D. Now what do you do? Do the same thing, right? X squared times x to the third. X to the fifth. X squared times 2x. Positive 2x cubed plus x squared. And now you have to do the same thing with the negative 4. That's why it's not, we call it distributing, because you distributed the x squared, now you're going to go back and distribute the negative 4. I'm going to leave you guys to the point where you guys can finish up the gathering of like terms. So minus 8x and minus 4. So gather up like terms on that one. Part E, I kind of put on there just for the fact that to kind of change it up. Yes, I think all of us would agree that's foiling, but I have square roots on there. We're going to have times where there's different pieces in there, whether it's powers, square roots, roots, all of those things. And so you still follow it the same way. So it's still 2. But what's 1 times a negative 3 square root x? It's not that hard, guys. Negative 3 square root of x. These pauses are going to get larger as we go along. What's square root of x times 2? 2 square root of x. And then we have a square root of x times a negative square root of x. This is the part that gets tricky for some of us. Square root of x times the square root of x will actually make what? X. So this is a negative 3x. So how many different terms are there? There's 3. The question is, how do you put this into standard form? Because technically a polynomial will have whole number exponents. A square root is what exponent? It's 1/2. So technically this would not be, fit perfectly. It's an expression. So it doesn't really matter overall. So I'll put the negative 3x first because it's kind of the highest power, which it is. And then let's go with the square root stuff. What's negative 3 square root x plus 2 square root of x? I have negative 3 of them, and I add 2 of them. I still have a negative 1 of them, and plus 2. So these two got added together, and then I put that at the end. So I FOILed. I still ended up with some like terms in the middle. The order on that could be slightly different if you were to check the back of the book or your neighbor. Now, going back to what we had on there before, where we had things that had to be FOILed, hopefully you've seen these already. Hopefully you start to realize that there are patterns to things in life. And so there's patterns to multiplying as well. I'd say the first three, these first three here, are probably the ones that you're most likely going to remember, if not already have. You have a sum and a difference multiplied together. We should all know what this ends up being. What's that first one really called? What is this part called? The sum and difference multiplied together to give you the, starts with a D. What's that? Not denominator. Not domain. Difference of squares. That's the difference of squares. Because most of the time, though, we go from difference of squares and factor it to a minus b, a plus b. We'll do that tomorrow. The second one is when you're squaring a binomial, which ends up leading to a perfect square trinomial. And it always ends up being a squared, the first term squared, plus 2 times the middles, the a and b, plus b squared. And the cool thing is that you don't really have to remember the third one. Because can't you take all negatives or subtractions and turn them into adding negatives? So when that's the case, you can revert back to number 2 and follow the same pattern. So what I did here was I just wanted you to take something that you see on the bottom here, A and B, and try to apply the patterns when you can. Will it take a little bit more time up front? Yes. But as we get going through here, and the more you do, it's the faster you're going to get. And that's pretty much what I have up there. And I think when we go factor, we're going to have the same one, but reversed. So 3x plus 5 squared. So using the formula, that's like formula number 2, right? It says that I can square the first term, square the second term on each end, multiply the two numbers inside, and multiply it by 2. That's what I'm going to do here. So what's 3x squared? The quantity 3x squared. Let's just write that actually. Let's just write it out first. So I get 3x squared plus 5 squared. Each of the corners squared. And then I can go inside and say, I'm going to multiply it by 2, take the first term and the second term. And now you just evaluate that, and you got an answer. So the quantity 3x squared becomes 9x squared plus 2 times 3 times 5, 30x plus 25. Done. I think possibly, I'm not saying possibly, it is quicker than foiling. Now, obviously, as we get going on this, you don't possibly need to write this out. You just know that you're going to square the first term, square the second term, multiply them together, multiply by 2. Boom, done. And I think it's a lot faster when you get to this problem over here, which is the exact same thing, but one is a subtraction and the other one is an addition. So in this case, you revert to case 1, sorry, and you just square the first term, square the second term, and put what between them? Minus. So what's 2x squared? So 4x squared minus? Done. That's how much easier these are. The thing is that they're not going to tell you, hey guys, hint, hint, use a formula to expand this. You're just going to be given a bunch of problems that says multiply or find the product. It is your responsibility then to eventually start to make a connection that every time you do one of these types of problems, it ends up being really easy, and I did a lot more work than I had to. So you start to see that up front. Homework is lesson 1.3, day 1, page 33. Let's do 1 through 33 odds. Have a fantastic day.